Do you have a MiSTer FPGA? Maybe something like this? Do you want to connect it to your CRT? Put in RGB, of course. Let's make our own cable. Hello and welcome to this video. There are a couple of high quality cables you can buy, like this one from Ultimate MiSTer. But if you're like me and you're in Australia, shipping might be more than the actual cable. And you'd also be waiting at least a week before you can get your cable. So today I want to show you how you can build one with off-the-shelf parts that you may already have laying around or can easily get secondhand. The first thing we'll need is a VGA cable. This one I've already cut one end. The second thing is a 3.5mm jack cable. Then we will need a SCART head and a SCART male connector. This one is brand new from AliExpress, but you can salvage these from an old cable like this one, for instance, that apart from America, you can find easily secondhand or in an old box of cable. Another part I would highly recommend is this PCB from Dan Citrus 3000 PSI. It's specifically for a male SCART head. It has the 5-volt line for blanking. Now that's one of those awesome projects that he's released, I think in 2018, and I've been using them for years. And they make the wiring for SCART male cables like these a lot easier and a lot more elegant. They are pretty easy to print. He's released the Gerber files, and you can just download that and upload them to a PCB making factory like a JLC PCB or PCBWay, and it will be probably less than $10 for 5 or 10 of those. If you don't have the time or don't want to print this PCB, you will have to do it manually, and it's going to look something like this. This is a AliExpress type console RGB cable that I've cut. The problem here you will see is that there's only one ground that used to be connected, I think, over there. Technically it might work, but it's far from ideal. There are many ground points that you ideally want to connect together, and you may have to do some kind of loops with wire to get it done, and it's fairly tedious, but it's totally doable. In this video I'm going to do it with the PCB, but the process is fairly similar either way. Okay, so now let's have a look at the diagram. It's a fairly straightforward cable. It's mostly a straight through cable. There's no components in line for the red, green and blue line. No resistors or no capacitors. Our audio cable goes on the left audio and right audio channel with the center dedicated audio ground. The MiSTer uses the horizontal sync, which is pin 13 of the VGA connector, to send composite sync out. And we are using pin 14, which is vertical sync, as the 3 volts needed for the RGB switch on pin 16. As we will see in a minute, our PCB connects pin 16 and pin 8 via a pad for a 180 ohm resistor. This is because most consoles send 5 volts, that is sent directly for pin 8, which is auto detect and aspect ratio, and then is brought down to 3 volts through a 180 ohm resistor on pin 16. While I'm here, I wanted to raise your attention to the 5-volt line that we will need for enabling RGB, and it's going all the way here to this VIA. On the other side of the board, we can see that this VIA is going here. Now, pin 16 here is absolutely required to tell the consumer TV to switch from composite to RGB. If we have 3 volts going to this pin, the TV is going to switch to RGB. There's no voltage here. It's going to try to display whatever is fed on the sync line as a composite signal. So for instance, if you were to use Luma as sync, you would see a black and white picture here. So for our project here, since we are going to use vertical sync to feed 3 volts onto pin 16, we don't need to drop it down. So in this case, what we'll do is we'll just jump those 2 traces here. Now let's talk about pin 8. This pin is used to auto switch to the RGB input Now this is not here where it switches from composite to RGB. This is to actually switch to the RGB channel of the actual TV. So if you were displaying RF and there is a certain voltage on pin 8, it will switch automatically to the RGB AV input on your TV. The other thing that this pin is used for is aspect ratio detection, and this can be a problem. On more modern CRTs, there is a 16:9 mode, and that 16:9 mode is enabled by having a voltage around 5 volts. To do the 4:3 mode, we need something closer to the 12 volt range. The issue is that most consoles, and the MiSTer in this case, do not have a 12 volt line available. And what that does is that every time you turn on the console or the MiSTer, your TV will switch to 16:9 mode, and you will have to manually switch it to 4:3, which is quite annoying. So if that is something that will bother you, I would advise to cut the trace here. Not here, obviously, because we need from the via to reach all the way to pin 16. That is required. Unless it's only required for consumer TVs and TVs that use the blanking from the SCART port. If you have some kind of internal blanking like an RGB modded TV with an external blanking switch, you can ignore this completely. Now let's have a look at the sync line. As I said before, on the MiSTer cable, we are going to use the horizontal sync that is outputting composite sync or C-sync. We need to drop down that voltage using a 470 ohm resistor. You have several options. We can put it here, although there's not a lot of room if you use a through-hole resistor. That'll be a bit messy. If you have a larger scale SMD resistor, this will be a good place to put it on. If you're not using these pads, you'd want to bridge this jumper. If you have a smaller resistor, like in my case, then you can just put it here and you won't have to use that jumper. Those jumpers are if you are not using the corresponding pads. Let's go for a soldering montage. So I'm using a lot of liquid flux here, soldering the 470 ohm resistor, tinning one pad first and then positioning it with the tweezers. It's really small, so it's hard to keep a steady hand, so that's why it's not quite straight. I'm confirming continuity with my multimeter every step of the way. Putting a jumper here on the 180 ohm resistor. Flipping the board over. Tackling the 3 jumpers for the RGB colors. Checking with the tweezers that we got a good mechanical bond. And again, using the multimeter to confirm. Moving on to the SCART PCB onto the SCART connector. A little bridge here that I remove with the desoldering pump. Flipping the board over. Another little bridge. Okay, so here we have the VGA cable that's already been stripped with all the important wires. So following the colors, we got RGB, and the gray and the white are horizontal and vertical sync. This big hunk of silver wire is the outer shielding. We don't need that, we can cut that off. These thin wires that are grouped together are different data and signal wires that we also don't need. And this wire here is actually all of the ground wires that were inside the sheathings. There was a thin foil around all these wires here, and I've joined all the grounds that were here. So now we will tin the ends. Let's have a look at the audio one. We have the white for left, the red for audio, and this one here is for ground. One important step before we solder our wires is to feed this part onto the 2 cables. Now let's solder. Good. Let's do a quick test fit. Okay, and now it's probably time to test. Okay, so we have our MiSTer here. We have our newly made cable in the SCART here. Let's connect it up. VGA port. Audio in. SCART male. Let's turn it on. Success! And that's it for today. Thank you for watching. I will catch you on the next one.